gentlemanly pose. Earth science time, we're talking about sedimentary now. Sedimentary and igneous rocks. I don't normally group these together. In fact, if you look at the videos from last year, I did not. But I meant to group all the rocks together, as your text does, but we ran out of time. So these are the ones that left. Remind yourself that we talked about the rock cycle, so we know how these rocks are formed. And we talked about metamorphic rocks, so we know a little bit about those and how they're classified. My goal, really, and the objective reflects this. No, it doesn't. But the objective is supposed to reflect this. My goal is for us to talk about, discuss the rock cycle and categorize. Let's use identify instead. Identify rocks. Identify rocks. Discuss the rock cycle and identify rocks. So basically, what I want you to know is how each type of rock is made, and then the specific categories within each type of rock. For instance, what are the categories within metamorphic rocks?
Non-foliated and foliated.
Are you alright?
Yeah.
Non-foliated. Give me an example of each, Captain.
Non-foliated and foliated?
Yeah, what's an example of a non-foliated rock? Non-foliated metamorphic rock.
Metamorphosed Sandstone, which is quartz.
Yeah, quartzite. Quartzite is the name of that rock. And then what's an example of a foliated rock, Kyler?
Marble?
Nope, marble's non-foliated.
I don't think we said it.
Oh yeah, we had a whole list of them. We had slate.
Oh yeah.
Slate, schist, nice.
Yes.
There's one other one. Let me show you some examples of this.
Nice.
Try to hold them up in front of the camera. So here I have an example of marble, and I'm going to also get an example of quartzite. This, that kind of works actually. That's quartzite. You cannot feel it because that's not how ASMR. Oh, okay, hold on, ring light.
Show us your test scores.
It did. It does. I showed them okay. I'm sorry. It is picking up. Some more. Quartzite. Okay, so you form a texture that is made of. They're not grains anymore. Metamorphosed, which is metamorphosed limestone. And the first thing we're going to compare them with are the sedimentary rocks these are made from. But this is marble. You definitely can't see that at all because of the whiteboard behind it. Something black. Marble. Not this. This is marble. Smooth. Okay. How can we tell that's marble? First of all, how can we tell it's metamorphic? Thing the first. By patting it?
No.
What's true of marble, of metamorphic rocks in general? Because they've been squeezed.
They have layers of bands.
Not always. Foliated rocks do have layers or bands. Because they've been squeezed while heated but not melted, they're usually what? What do we call it? It has the same mass but in a smaller space.
Dense?
Yeah, they're usually denser. That's not the best way to tell, but it is one of the ways. One way we can tell if it's a metamorphic rock as opposed to a sedimentary rock is that usually sedimentary rocks will be, you can flake off or scrape off or peel off individual sediments, whereas that is certainly just a solid mass. And then the way you can tell them apart from igneous rocks, which is what we'll do later on, is that igneous rocks are made of crystals. Like this is a piece of probably granite. And you can see the individual crystals. Even the camera can see them. Can you see them, camera? Kind of, if I'm taller. Whereas this, you can see some of what used to be grains, but they were metamorphosed together. The object in question here is the quartzite, not the marker.
You go to your countertop and just break off the piece?
Anyhow, no, that's marble.
I know.
You might look like I have marble. Don't at me. So what we're going to look at now, I want to show you a piece of slate. Where else can we find slate in this classroom?
On the
chalkboard. The chalkboard is made of slate. That chalkboard is actually the true natural slate. Not all chalkboards are. So we're getting kind of into sedimentary rocks now too, but look at this piece of, where did it go? Shale. This is shale, sedimentary rock. It has layers, but we don't call that foliation because it's a sedimentary rock. But this is made of flat minerals, and they're all kind of layered together. It's shale. And they're just lithified, which means they've been squished, but not necessarily heated and super pressurized. And this is slate, which is this boy after he's been exposed to high heat and pressure. How can we tell them apart?
Because
No. Well, first of all, the density. The slate is denser. But how? Do you remember I gave you 2 ways you can tell them apart?
okay, I know you can't do that, but they're different colors.
Yes, they are different colors. That's not how you can do it. The slate can be black. I'm sorry, shale could be black. Slate could be gray.
The one makes like a color, the one makes it clean.
Yeah. Neither of them do it very good. If we had a better table, maybe. I'll do it by the microphone. Come here. That was not the sound of one. That was my water bottles. That was supposed to be clunk. That was supposed to be
like a clunk.
I'm sure I have them right. Another way you tell them is if you get them wet, the shale smells like earth because it's non-metamorphosed. Anyway, once this is exposed to some metamorphism, what we call low-grade metamorphism, it becomes the slate. And if it's exposed to a little bit more, pass those around, there's 2 of you. If it's exposed to a little bit more, it becomes schist, which is even more dense. This is garnet schist, which has chunks of garnet in it. That would not become this because that doesn't have the mineral makeup to become garnet. But some other rock would become this schist. Which you can see the banding in this, right? That's the whole point of these ones are foliated as opposed to these, which are non-foliated. Non-foliated, let me get them out of here. Non-foliated, so no banding. And then these 3, these 2 are foliated, so there's banding. See the banding, YouTube stars? What did I say? Zoe 101 fans? Was that?
Yes.
There's banding, okay? And then with even more metamorphism, it would become this gneiss. And the banding, this looks kind of stripy, like a zebra, but the banding is actually the other direction. So the banding is in this way. Hello, this is nice. And then this is also nice. I'm just holding up the exact same thing, the literal exact same thing. Nice. Nice.
Nice.
Let's just start with that. Nice.
Good nice.
All right, good. Now that we've got nice out of the way. Those are all what kind of rock?
Those are all metamorphic.
Metamorphic.
Yeah.
Except for the shale, which is sedimentary. Let's do the sedimentary now. The first way we break up sedimentary rock into large categories is in the way they were made. Most are plastic, like plastic with a C. Some are chemical, and then fewer, still some though, are biochemical. And by some and less and more, I'm talking about the number of types. It very well could be true that most sedimentary rocks on planet Earth are chemical. I don't think that's true. But I'm talking about the number of types. So classic sedimentary rocks are judged by their, what we call grain size. What might I mean by grain size?
By like, you know, like, if it was made out of like pieces of gravel compared to pieces of salt
exactly right.
or something like that.
Exactly. The size of the grains is how big the chunks that make it up. Classic sedimentary rocks, these are made out of chunks, other stuff. Chunks of other stuff. Oops, what did I do? Clast is related to the Greek word for broken, which is klastos. Excuse me. This is not a word you might be familiar with, but there's this idea in some religions have what are called icons, and there's this idea of iconoclasm where one of those icons is broken, and there's a metaphorical and a literal meaning to that. But clasm there is the broken down, an icon being broken. Iconoclasm, clastic rocks are rocks made of broken down bits of other rocks. So starting with the largest grain size, so big grain size down to small grain size, we have, this is what's called conglomerate, which is rounded grains, or breccia, which is angular. What might those two things mean? Angular and rounded. What are we going to look at to tell if the grains are angular or rounded?
Maybe a piece of quartz?
Yeah, but I mean, what are we going to, how will we tell if a rock has angular grains as opposed to rounded grains? Basically, the conglomerate is going to end up looking like this with little round chunks in it, and the breccia is going to look like this with pointier chunks in it. The example I have here is kind of, there are some rounded and some angular in this. This is over there. There we go. This is conglomerate. Thank you.
Well, doesn't that have some in it?
This is a metamorphic rock. What we're talking about only applies to sedimentary. So that's conglomerate. I would classify that as conglomerate. You could make a case for it being breccia. The breccia really does have to be quite angular. I used to have a piece of breccia in here, but I must have forgotten it in the lab. I'm not going to spend my time going into getting it. So conglomerate and breccia is what we call the largest grain size. And the next down we call sandstone. Sand, you know about sand. You've been experiencing sand your whole life, yeah? But sand, specifically in geology, is a certain size of grain. Your book will tell you what size sand must be. But sandstone is rock made of sand-sized grains. The one way you can tell sandstone, apart from the next one down, which is what we're going to talk about in a second, is that it's more rough. The chunks are bigger. So just like the conglomerate, rougher, we would say, than the sandstone. The sandstone is rougher still than the next one down, which is silt stone. We'll revisit these later in the year when we talk about sedimentary environments because they directly relate to how much energy a system has. Basically, it's super windy today, isn't it?
Yeah.
If you walk and the wind's hitting you, you can feel the sand hitting your face.
Yes.
Usually, if it's less windy, the wind doesn't have enough energy because it's not moving fast enough to carry sand. So sometimes you might feel dust hit your face, but if there's no wind at all, not even dust can be carried. Effectively, the faster a certain medium is, the larger the grains it can carry. And so, just being able to call it sandstone is cool, but that also tells us a lot about where it was formed. And we'll talk more about that when we do sedimentary environments. And then the smallest kind is called, I'm trying to find the silt stone still. But the smallest one is shale, which is made of clay size. And then the size of these is sand size grains, silt size grains, and clay size grains. Clay are the smallest grains. And you already have the shale there, don't you? So that's a sedimentary rock with clay size. What does a sedimentary rock called shale feel like when you just feel its surface? Feel it.
Kind of powdery.
Well, okay, the powder is from the other rocks that are in there right there. But if it were powdery, compared to the sandstone, it feels what?
More smooth.
Yeah, it's smoother because it has smaller grains. And so basically on a microscopic scale, the sandstone looks like this, and the shale looks like this. And so when you feel it, it feels smoother because it has smaller grains. Aye?
Yeah.
That's all plastic sedimentary rocks. I'm going to do chemical in a different color and biochemical in a different color still because I've kind of run out of room here. So chemical sedimentary rocks, we're going to do in this Heinz 57 sauce colored stuff. Chemical. And these are sedimentary rocks. Instead of being made of chunks of stuff glued together, they're made by, for instance, you're making chemical sedimentary rock in the lab right now. Technically, rocks have to be naturally occurring, but what you're making is like how a chemical sedimentary rock is made. So a lot of these are called evaporites, which is where they're made from water with minerals dissolved in it. And then what happens? Step one is water with minerals dissolved in it. What's step two? The water does what? There's a hint in the name.
Evaporates?
Yeah, the water evaporates. And then step three is the minerals are deposited. Some examples of this are limestone, rock salt, dolomite. There are lots of others, but those are just some examples. That one has shells on it, so it doesn't matter. This is an example of limestone. How can we tell the difference? This does feel kind of rough. Maybe not as rough as the sandstone. How can we tell if it's limestone versus sandstone? First of all, we would know about the environment where it's formed. Obviously, it would be in a different environment. But if we didn't, just having samples of the rocks, limestone made of the mineral calcite, which we talked about last time, how could we tell it's made of the mineral calcite? Remember what was special about the mineral calcite? Marble is made of the same mineral, because it's metamorphosed, so it doesn't do this quite as strong. But there's a chemical reaction we can do in the lab or in the field that will tell us that it's calcite. Do you remember what it is?
No, but I can tell you what it's.
Go back to your. Where's your mineral identification chart? What did you use to tell it was calcite? It had a special property that told us it's calcite.
Oh, it dissolves, bubbles when you put.
Yeah, so if you put a tiny little bit of hydrochloric acid, or really any acid, the bubble will be generated. And so if we did that on that limestone, it would tell us that's limestone as opposed to sandstone. Like I said, there's usually an easier, better way to tell, which is that we can just look at the mineral where we got it formed. And the last category of sedimentary rocks is, these are all sedimentary, is biochemical. What is this obviously going to entail? Made by what?
Made by people?
Not usually people.
Made by unnaturally occurring, I don't know.
It has to be naturally occurring, but living things. Things that, there are living things that aren't people, made by living things. In fact, if they're made by people, they don't count as rocks. Remember, one of the requirements for minerals was that they had to be inorganic. That's not true of rocks. Rocks have to be naturally occurring, but they don't have to be inorganic. So this category of biochemical are made by living things. What might some examples of rocks made by living things be? Well, one of them is what we call, go ahead.
No, you go ahead.
Well, you go ahead.
I was going to say, don't some people make like marble?
Some people do, you're saying, but I'm saying what animals make something that we might consider rock? Well, for one thing, we have any kind of rock with a fossil is called fossiliferous. One common one is fossiliferous limestone. Another one, if it's entirely made of fossils, we call it coquina. And then another very common one is coal. There's even one kind of metamorphic rock that's made of coal, which is called anthracite coal. This is not it. This is kind of low grade, what's called bituminous coal. This is bituminous coal. It's made by living things millions of years ago, and then got compressed, liquefied. This one is fossiliferous limestone. This is limestone. Sorry. Here you go, camera. Here you go, camera. This is, see the little, see them?
This looks heavy, right?
This is limestone with snail shells.
This looks like it'd be so heavy.
Limestone with snails. And then there's another one in here.
Oopsies.
Oh man, I hope I didn't forget my coquina, because that's the coolest.
What? This one's really cool.
Mm-hmm. Yeah, those are all snail shells.
That's awesome. This is a rock.
Oh, heck me, why do I?
See?
It isn't.
It looks like a house.
It looks like one.
Okay, well I'm missing my sample of coquina. Okay, check out, this is technically a sample of coquina, because it's a fossil, the rock is entirely made of fossil. It is a fossil snail. It came off of there, actually.
It looks like a rattlesnake.
It does, but it's actually some kind of helix snail shell.
Candle goes around.
Oh, well, guess what? We don't have time for igneous rocks either. We'll do another video. This one-part video is now a 3-part video. Bye!